Yeah, my name's Paul Burbage, and today I'll be giving a talk on a passion project of mine that I've been working on for about 3 years now. So let's get on it. A little bit about myself. I'm a malware researcher. Previously did a lot of web pen testing, so you'll see how that kind of comes into play with this particular project. I like to play the drums, and I was active duty Marine 2004 to 2008. Feel free to reach out to me there on my Twitter or my personal email. Go over our agenda for today. So we'll talk about what the problem is. You know, it's far too easy for these skids to grab these commodity malware kits and use them to breach an organization. To understand how the system works, you know, I'm probably preaching to the choir, but we'll go over what is stored cross-site scripting, and then dive into the system details itself. You know, how we're able to insert these stored cross-site scripting callbacks, as well as what that receiver looks like whenever we receive that beacon reply. Also touch upon the legality of this particular system, you know, being a researcher that lives in the United States. So wanted to touch upon that. And then also have some case studies I'd like to go over from the data that we've collected here for almost 3 years. Finally wrap that up with the conclusion and Q&A. So what is the problem? As I mentioned earlier, I mean, anyone can go out to these websites or develop a forum account and purchase malware or download it for free even. And these breaches are occurring, right? It seems like Crabs on Security is reporting every day that, you know, these organizations are being breached. And in my opinion, the current attribution, it's one-sided, right? It's grouped by shared infrastructure, similar distribution, TTPs, or remnants within the malware code itself. So we need to have better attribution. And one way that we can do this is to beacon actors inside when they're utilizing that malware command and control. Briefly, you know, again, just touch on stored cross-site scripting. So this is whenever a web application is vulnerable to an attacker executing malicious script. Actually, the most common vulnerability in web applications today, even more so in malware command and control compared to legitimate software that might be going through some sort of Q&A process, right? Stored cross-site scripting is persistent. So this is whenever the payload is being stored within the database, inside a server-side file, or within session information. Then it's printed out to the web application user, in this case, the malware actor, and without any type of script filters. So although it is possible to inject HTML, JavaScript, and so on, with this particular system, we're only doing benign image callbacks. And I'll touch upon the reason why when we talk about legality here in a little bit. Understand how the system works, kind of wanted to touch upon, what is a malware C2? Again, it's, this is something that I'm sure most of the folks on this call will, know about, but all of the infected nodes communicate with the C2. You can think of it as an API in the underground vernacular. Most actors refer to this as the gate. And then you have the adversary, which logs into the malware C2 and is able to issue commands or retrieve exfiltrated information from those infected nodes. Logging into that C2, the malware actor might be presented with something like this. This is an example of a form book C2 software. So as you can see here, you're able to see all of the different machines that the actor has under his control, and he's able to execute commands from that, as well as grab any type of exfiltrated information that was taken from that system. Dive into the system details. So again, we're using stored cross-site scripting to insert beacon callbacks. And we actually have two different payload injection methods. One is the manual insertion, where we write a fake bot code to check in, and then an automated hooking where we modify cuckoo, and I'll talk about that here in a little bit. And then the second part is just the receiver, right? We have a receiver running that just logs all of the information, the callbacks from these beacons, and then stores them in a database, and which is presented to you in a search capability on malbeacon.com. going over some of the manual injection steps. So this requires, the researcher to analyze the C2 source code for stored cross-site scripting vulnerabilities. So we have to have a copy of that C2 source code, right? Then from there, we have to reverse engineer the check-in process and write actual bot check-in code with that payload insertion. So the pros of this, it's sniper-like precision. And from that, we have a high beacon callback rate. But the cons is, it's very time consuming. And as you can imagine, if that malware family is still under, active development, then we unfortunately, would have to go back to the drawing board to see if that family is still vulnerable, as well as rewrite our bot check-in code. One of the other methods is an automated solution, where we hack the monitor DLL for Cuckoo Sandbox. So anytime that malware sample is running, if it's using some type of Windows API, like get username X, we hook the return and taint the return information on that, and we're able to insert our beacon code. So the pros of this particular method: scalable, right? No reverse engineering of the malware family up front, and it's not affected by malware changes. One of the families I'll talk about here when we get down into the case studies is that KPOT or CROT info stealer. For the long time, it was susceptible to beacon callbacks. And although the malware actors, they were changing the C2 protocol check-in, just by running the sample in a modified sandbox, we were still able to get callbacks without having to write new bot check-in code. So it casts a wider net, and it's more or less spray and pray. And with that, it's quite noisy, right? So best case scenario, if particular family is not vulnerable with the automated injection, best case scenario, that check-in that is hooked, it's just dropped by the C2. Worst case scenario is that beacon callback is not rendered, and the actor who logged into that C2 can see our callback infrastructure, leading to obvious OPSEC concerns there. Wanted to touch upon the receiver, what that looks like. So again, benign image requests coming in, just doing some HT access trickery, taking those image requests and rerouting them to a PHP file. That particular PHP file just pulls out everything it can from the request itself, everything from the source IP, the HTTP refer field, which is very interesting, in that this is going to be the URL to where the C2, where the actor is accessing that C2 at the particular time of callback. Within some of the manual injection methods, we're also able to submit a UID within the image name. So this is really cool, especially with families that might utilize, Nginx proxy forwarders. So we're able to submit a unique ID, and when we receive a callback, from that actual admin interface, we can map that back to all the different proxy gates, back in that this particular campaign is using for the malware sample, right? And then the user agent, of course, this can be spoofed, but in the event that it's not, this tells us quite a bit of information about our attacker. Everything from their machine architecture down to the operating system and their web browser preference. And then finally, we send a 1x1 pixel image back within that reply to the beacon request, right? Reason why we do that is as long as it's rendered properly within the C2 panel, as that actor's logging in, it's not going to mess any of the HTML formatting up. And one other thing that we do within that reply is set a persistent cookie. So this has been really interesting to cluster some of this information. So what we can do now, setting that persistent cookie, even though the actor might be changing C2s, as long as they're using that same browser session, we're able to capture that information. So they can change the C2 domain URL. They could be using different malware families even, and we're able to track that and cluster it into what's essentially one threat actor group. That's exactly what I did here with 1 month of data. As you can see, was able to cluster 134 unique domains or IPs to a unique threat actor group, which I thought was pretty cool. wanted to touch upon the legality of this. So I went through several rounds with the EFF, the Electronic Frontier Foundation, right? And they came back and said, you know, as long as you're not doing any type of code execution, should be fair game, which we're not, right? We're not doing JavaScript, so we're doing solely benign image callbacks. This is no worse than any type of advertisement. You know, I bet if anyone, you know, pulls up their email on their phone or, you know, takes a look at that raw source of the email, there's going to be these tracker pixel requests within those emails. It's nothing worse than what we, you know, come across just from advertisements from day to day. There's no authentication bypass, right? So no issue there with the CFAA. Any issue with, you know, stealing cookies, we're not doing that. Again, we're not inserting JavaScript to steal cookies to log in to the C2. You know, that's not what we're doing. Just wanted to keep the system ethical and, you know, legal. And it respects the privacy. So we're solely inserting the beacon through the gate interface of that malware C2, right? Not inserting it through the admin interface. So the only way that these beacons are tripped is if a malicious individual logs into that malware C2 and you know, fires back that beacon. Normal, you know, internet users casually browsing the internet, they're not going to be tripping these beacons just by you know, checking their PayPal balance or whatever. Good to go. Dive into some of the case studies. Again, I've been collecting this data, you know, for almost 3 years. BlueLib calls them Air9. Talos, I believe, labeled them TA545. So these guys were utilizing the onliner spam bot to send Canada Post.zip attachments. These zips contain the Rs VBS loader, login screen pictured right there. From there, the VBS loader called into the C2 and asked, you know, what additional malware would you like me to load? In these particular campaigns, it was targeting Canadian financial institutions customers, as well as loading Zero Evil, info stealer. Zero Evil, by the way, also the same author behind Rs VBS loader. So it got some pretty interesting callbacks from this particular campaign, adversary IP, tracing back to a dedicated VPS, Windows VPS in UK. So the CERT Canada guys were you know, pretty interested in receiving that. Some I think actually on this call here, and then confirming in Shodan that IP address was a Windows 10 64 box, as well as what the user agent revealed there, and that these guys preferred Firefox. Second case study. So this is a pretty ongoing threat from what I've seen. You know, with a lot of people doing the whole cryptocurrency craze, if you will. These guys will stand up a fake website that mimics a cryptocurrency wallet software. And from there, you know, just casual people browsing for that particular software on the internet stumble across the site and they'll download malware. In this particular campaign back in September of 2018, they're downloading KPOT or KROT, which is the Russian word for mole. It's an info stealer. Adversary IP tracing back to a provider in Russia, and the user agent utilizing the Windows 8 64 box of all things, using the Opera web browser. So this system not only works with commodity info stealer, but it's also worked for APT. Back in January of 2019, a piece of mole rats malware came across my desk. And again, did not have to reverse engineer the malware check-in process to fuzz that, you know, particular protocol, because we obviously didn't have a copy of the C2 source, but just tossing that into our automated sandbox, those functions were hooked and the beacon payload was submitted. And sure enough, this particular family was you know, traced back to Gaza Cyber Gang, and the beacon itself you know, came from residential ISP in Gaza Strip. One pretty cool thing about this family is that it was utilizing multiple Nginx proxy forwarders. So not only in that HTTP refer field, we're able to get this, you know, back.clouddns.cc, the actual true backend domain name, but it was also utilizing this strange user agent of twos. And in order to even access the panel, the malware actor had to have that specified for that user agent. It's pretty interesting. So that was pretty unique hard-coded artifact, and by searching that particular two's handle across social media profiles, may or may not have found a couple people attributed to this particular cyber gang. Good to go. Just wanted to touch on some statistics. Going on better, about 3 years, almost 3 years. Yeah, little over 27,000 attacker source IP addresses enumerated, 31,000 malware C2s, and as far as the raw beacons received, close to 350,000. So it's been a pretty fun project to work on and a really nice data set to leverage. So in conclusion, yeah, I just want to scale out Cuckoo, right? Maybe add some extra hooks in there for the different Windows API calls. And then the clustering of beacons. So starting to look into more or less, for lack of a better RSA floor buzzword, machine learning or, clustering of those particular persistent cookie beacons that we received there. And extend support to other operating system malware, especially within the automated sandbox. So looking to support Mac, Android, and Linux malware families. And then finally create an API to access the data. I've been actually working on that the past week or two. My hope is to work with a couple other people to write a Maltego transform and whatnot. So it's coming along nicely. That being said, if you're on this call, and you're interested, feel free to join the MalBeacon Slack channel. And if anyone does not have an account, you can hit up that short URL there. It doesn't go to a Rickroll or anything. Just request some information here and there as far as verifying who you are to make sure I'm not giving access to any miscreants. That's about it. I wanted to thank the organizers, not only for one of my favorite Slack channels of all time, but also to, for putting this together. I really appreciate the invite to come and speak to y'all. Thanks.